Hello. In this video, we're going to talk about the fisheye camera implementation in the Unity. All right. So what you're seeing here is a sphere that reflects the surrounding. Okay. And what you see on the left is the top view of this sphere. So the actual fisheye camera view is what you see on the left. Okay. So if I move this sphere or the fisheye camera, if you pay attention on the left, you can see its reflection of the surrounding is real time. Okay, so it's real time. If I change the orientation, you're gonna see the reflection of the world. Okay, so the reason that you can see all this in real time is because I'm using shader to actually utilize the GPU to do the reflection of the world around on this sphere. Okay, and let me jump into a little bit of the theory how I created this reflective sphere and eventually created a fisheye camera. All right, so if I start with the the architecture of this fisheye camera, it consists of 5 cameras inside of this sphere. Okay, those include forward-looking, right, left, rear, and upward-looking cameras. Okay, so within this sphere, I have 5 cameras looking outwards. And what I do there is that for each camera, I project whatever that it sees onto this sphere. Okay, for 5 different cameras, and I stitch it on this sphere, and that's how what you're seeing here. It's the reflection that is basically the projection of the camera onto the sphere. Okay, so that's the idea. And then finally there is a orthographic camera that is looking directly on this sphere from the top, and that's the view that you're seeing on the left here. See over here, around somewhere up here, yeah, up here, it's directly looking down on to that sphere, and that's the view that you're seeing on the left. Okay, so that's the idea of this fisheye camera. And the programming part is very simple. I have just one vertex fragment shader that does this projection of the real world view onto this sphere. More specifically, what it does is that for each camera, we have the texture, like it says here, it's shown here. And on the surface of the sphere, I can find out the position of the surface of the sphere. Then I can correlate that position to the corresponding camera, and furthermore, the UV coordinates of the texture that it captures. Then I sample that color of that UV coordinates and put that onto the sphere. So that is the general idea of the projection. Okay, so let me jump into the code, explain what's going on in this shader code, and that will summarize today's presentation. So here in the shader, I have 5 different textures as a property. Okay, so if I look at the material that I created with the shader, fisheye, you're gonna see you see down here, I have 5 textures, right, corresponding to forward, right, left, back, and top. Okay, cameras. All right, then the first thing that I do is I get the vertex information of the any point on the surface of the sphere. Okay, and then I convert that into heading and pitch angle. So center is the sphere center, and relative to the sphere center, we can compute the heading and pitch of each point on the sphere. Okay, each sample the points. Then using the heading and pitch, we can find out, first of all, which camera that we utilize. Okay, so if the heading angle is between these values, it's going to be the right camera. If the heading angle is between these values, it's going to be forward camera, and so on. Okay, so once we find what that heading angle, what the camera that we're looking at through the heading angle, then furthermore, based on the position value, we can convert that into UV coordinates of that texture, then we can, we can query the color. But it is one more thing. If the v coordinates, normalized vertical coordinates, if that value is less than 1, then we can just query whatever that camera is looking at. But if that value is greater than 1, now we're going to have to look into top view camera. Okay, so from the right camera, based on the computation of the v coordinates, if it is greater than 1, then we're going to move on to the top view camera and then recalculate the uv according to the top view, and then we query the top view, the texture. Okay, so that's the general idea of how we create this, how I program this shader. And based on the shader, we create a material and we put that material onto this sphere, and from there, without running the Unity, it just works as it is. Okay, all right, so that's it for this video. The camera model as well as the source code is available in the GitHub. I put the description below in the I put the link in the description below. All right, thank you so much.